Hi, welcome all. Today we are going to study how to solve simultaneous equations by determinants. So this is a part of your paper electrodynamics. This is presently the fifth semester BSc and also the fourth semester BSc Physics course of Calicut University. So the chapter is network theorem and the topic is solving simultaneous equations, and this is basically for Kirchhoff's law, solution of Kirchhoff's law. So when we apply Kirchhoff's law, there will be equations because in complex circuits there will be many closed loops, and each closed loop will produce one equation, and simultaneous equations will come. And how to solve the simultaneous equation by determinant method. So first of all, what is a determinant? I told you it is a collection of uh, numbers or having rows and columns. So if I have two rows and two columns, we call it as second order determinant, and the numbers are called as elements or constituents, and the evaluation of such a determinant is done by the cross multiplication. So how will you find the value of a determinant? So if I have a 2 by 2 determinant of second order, so you just cross multiply AD minus BC. So that is what the value of the determinant. So it is very easy to find the value of a second order determinant. That's AD minus BC. So if I want to find the value of a third order determinant, so third order determinant has 3 rows and 3 columns. So there will be 9 elements. So how to find the value of the third order determinant is simply multiply the each element of the first row by the determinant obtained by omitting the row and the column in which it occurs. So and then add it. So you can see here, if I want the first row, I omit the first row and the first column, and you got a determinant, a second order determinant, and then you find the value of the second order determinant. And in the second step is you are finding the omitting the first column and the second row, and then you will get the determinant, minor determinant, and then simultaneously you complete the third one. So prefix, the second step is prefix plus and minus sign alternatively to the terms obtained, and add all these terms which we obtained, and then you get the value of the determinant. So for example, if I have the third order determinant, so the A1 into the minor determinant is B2 C2 B3 C3. So like that, you know how to find the value of a second order determinant. You find the value of the second order determinant, then multiply with the A1, and then you put a minus sign in the second term and plus sign in the third term. Like that it goes on. So now I will solve a problem. We have a determinant minus 7 minus 3 minus 4 minus 3 6 minus 2 minus 4 minus 2 11. So we will expand with the help of the first column. So you can take a first column, or else you can take the first row also. So if I am taking the first column, so take the first column, first element of the first column, and then omit the first column and the first row, because it is in the element is present in the first row and the first column. So what we get is the determinant 6 minus 2 minus 2 11, that is a minor determinant, and the value is AD minus BC. So 6 into 11 66 minus BC, minus 2 into minus 2 is plus 4. So 66 minus 4, that is 62. So 62 into 7, and that will be the first value, and then the second value is A2, that is minus 3. So you have to put minus already in the second term, so minus of minus 3 is plus 3. So that into the determinant, minor determinant is minus 3 minus 4 minus 2 11. So find the value of this determinant, and finally you will do this process for all these things and add all the terms. Finally you will get the value of the third order determinant is 191. So how will you use this method you know how to find the value of a determinant. Now I am going to show you how to use this knowledge to solve any simultaneous equations. For example, I have two simultaneous equations and there are two unknowns. I have ax plus by is equal to c, dx plus ey is equal to f. So the two unknowns x and y, and the coefficients are a, b, c, d, a, b, d, and e, and c and f are the constants. So now what I do is I convert this simultaneous equation into matrix form. So the matrix form is the coefficient matrix into the variable matrix equal to the constant matrix. So here we have the coefficients are a, b, d, e. So the coefficient matrix is matrix a, b, d, e, and the variable matrix is x, y. So it's a column matrix, and the constant matrix is one column matrix, that is cf. So now we got the common determinant is given by a, b, d, e, the value of this a, e minus d, e, b, d. And now find the determinant for x, replace the coefficient of x in the original matrix by the constant, so that we get determinant d delta 1. So what I do is, to find the determinant for x, what I do, you have to replace the coefficient of x in the original matrix. So you can see here cf is the constant matrix, and then you have to coefficient of x means ad has to replace by the coefficient constant matrix. So in the common determinant or in the coefficient matrix, what you have to do, x comes in the first column, so you replace that elements of the first column by the constant matrix, elements of the constant matrix, so cfbe. So that is what the determinant for x. So now find the value of the determinant of x, that is ce minus fp. And then you find the determinant for y. How will you find it? You replace the second column, that is the elements of y, with the constant elements. So that is be is replaced by cf. So you'll get a, d, cf. So now find the value of the determinant delta 2. That is the determinant delta 2 is af minus cd. So now what you do is apply Cramer's rule to get the value of x and y. So what is this? X is equal to delta y1 delta 1 by delta. So that is delta 1. Delta 1 is the determinant for x, that is divided by the common determinant. So ce minus bf by delta. And now how will you find the value of y? So the value of y is found by the determinant of delta 2 by the common determinant. So delta 2 is what? Delta 2 is the determinant for y. So that determinant for y is to be divided by the common determinant. So delta 2 is af minus cd, and that you have to divide by the ae minus bd. So now we got the values of x and y. So this is how to find the values of x and y using the determinant method, or we have solved the simultaneous equations using the determinant method or matrix method. So for we have a example, I have two equations, 4i1 minus 3i2 is equal to 1, 3i1 minus 5i2 is equal to 2. So now how to solve these two equations using matrix method or determinant method? Now first of all I write the coefficient matrix 4 minus 3, 3 minus 5, and the variable matrix i1, i2, constant matrix 1, 2. Now find the common determinant. Common determinant is just find the determinant of the coefficient matrix. So that is 4 into minus 5 minus 3 into plus 3, that will be minus 11. Now find the determinant of x. So the how will you find it? Replace the first column by the constant matrix. So that will be 1, 2, minus 3, minus 5, and then find the value of delta 1. Delta 1 will be the value of the determinant 1 minus 3, 2 minus 5. So that is what the determinant of x. So that is delta 1. And now find delta 2. Delta 2 is the determinant of y. So how will you find the determinant of y? Replace the coefficient matrix. The second column is to be replaced by the constant matrix. So the second column is minus 3, minus 5, and that has to be replaced by the constant matrix, that is 1, 2. So you will get delta 2, that is 4 into 2 minus 1 into 3, that is 5. So that is what delta 2. So now after finding the value of delta 1 and delta 2 and delta, you can easily find the values of the unknowns, that is x is equal to delta 1 by delta. In this case i1 is equal to delta 1 by delta, i2 is equal to delta 2 by delta. So here in this 1 by minus 1, minus 11, so that is minus 1 by 11, delta i2 is equal to minus 5 by 11. So thus we come to the end of this class.